Good afternoon, everyone. I am Ed Christian Echompok, and to my co-reporter, Natasha Grace Capuzan. We were assigned to discuss Lesson 8, and it's about corrosion and its prevention. So, what is corrosion? Corrosion is an electrochemical reaction involving an anode and a cathode. So, ang kanang electrochemical reaction typically occurring at electrochemical cell. Ang kanang electrochemical cell is naduha na siya ka material that is submerged or partially submerged sa isa ka electrolyte solution nga diha gakahitabo ang loss and gain of electrons. Ang isa na ka material is anode, ang isa na ka material is cathode. Deterioration of a material because of reaction with the environment. So ma-deteriorate gyud ang isa ka material kung ma-expose na siya sa bisag unsang environment. Like for example, ang kanang lansang nara na siya sa lamisa, wala na basta mag-corrode gyapon na siya since ang air na ay oxygen, and oxygen is one of the main drivers of corrosion. Combines many elements of engineering and impacts all engineering disciplines: chemical engineering, mechanical engineering, material engineering, electrical engineering, and civil engineering. So requirements for corrosion. Ang requirements for corrosion natay anode and cathode. Sa kung giingon ganina nga electrochemical cell, dabay duha ka material. Ang isa nila kay anode and cathode. Ang anode diya gakahitabo ang oxidation. Sa cathode diya gakahitabo ang reduction. Since oxidation is loss of electrons, diya pa gakahitabo ang gaka-occur ang corrosion. Three factors that govern corrosion. So naatay metal composition, the metal from which the component is made. Ikadua, protective treatment for metal surfaces aim to prevent or slow down corrosion. Ikatulo, metal conditions, the environment in which the component is kept. So, three ways in which metal corrodes. So, naatay dry, wet, and galvanic. Kaman ka og dry are also known as chemical corrosion. It is a type of corrosion that occurs without moisture or water and occurs due to high temperature and without liquid phase. So, most of the corrosion-resistant metal, such as lead, zinc, and aluminum, form a dry oxide film in which protect the metal from further atmospheric attack. Wet or electrochemical corrosion, from the title itself, type of corrosion, wet, which is nag-involve siya og liquid, occurs when aqueous solution or liquid electrolytes are present. So wet corrosion takes place in environments where the relative humidity exceeds 60%. So muna siya ang difference between corrosion and between dry and wet corrosion. So dry corrosion occurs in the absence of moisture, whereas a wet corrosion occurs in the absence of in the presence of conducting medium. Kanang ginapasabot nga conducting medium mo ni siya ang katong electrolyte solution, seawater, basta mga katong mga liquid. It involves direct attack of chemicals on a metal surface, whereas the wet corrosion, it involves formation of electrochemical cells. The process is slow. Corrosion products are produced at the site of corrosion, and then the process of corrosion is uniform. Sa wet corrosion, it is a rapid process. Corrosion occurs at anode, but rust is deposited at cathode. It depends on the size of the adonic part of a metal. So, galvanic corrosion. Ang kaning galvanic corrosion occurs when two decimal metal such as iron and tin or iron and zinc are in intimate contact. They form a simple electrical cell in which rain, polluted with dilute atmospheric acid, acts as an electrolyte and generate and circulate within the system. So natay type of corrosion. Common types natay general attack corrosion. Muna siya ang very common form of corrosion that attacks the entire surface of the metal structure. Natay localized corrosion. Localized, that means specifically targets one area of the metal structure. So ang localized na ay type na siya pitting, crevice, o filiform. Pitting is a form of corrosion in which results in holes or cavities within the metal. Anong ka o crevice corrosion? Corrosion that occurs in stagnant water, often at joints such as bolted connections. Kung maingon ka o filiform corrosion, it is a type of corrosion that looks like little worms sa under the coatings or paint sa isa ka metal. Again, natay galvanic corrosion o environmental cracking, combination of environmental conditions affecting the metal na siya types, na siya stress corrosion cracking, corrosion fatigue, hydrogen-induced cracking, liquid metal embrittlement, o amo to siya. Again, napod tayo isa ka type of corrosion, flow-assisted corrosion. Kung meron ka o flow-assisted corrosion, kay isa ni siya ka corrosion mechanism in which a normally protective oxide layer of a metal structure, metal surface, dissolves in a fast-flowing water. Unang flow-assisted corrosion. Intergranular corrosion. It is a form of corrosion where the boundaries of crystallites of the metal are more susceptible to corrosion than their insides. Dealloying or selective leaching. Selective removal of one element from an alloy by corrosion processes. Fetting corrosion. Special type of erosion corrosion which occurs at the atmosphere rather than in aqueous solution. High temperature corrosion. Muna siya ang degradation of metals or materials, specifically metals and alloys, when exposed to elevated temperature in aggressive environments like oxidizing atmospheres, sulfur-containing atmospheres, chloride rich environments o uban pa. Generally occurs at temperature above 300 Celsius, but can extend significantly higher depending on the metal and specific conditions.
Thank you, Ed. As what he said, our topic is about corrosion and its prevention. This is an important topic as corrosion can significantly impact the lifespan and integrity of materials and structures. As what Ed discussed, that corrosion is the deterioration of metals, usually metals due to chemical reaction with their environment. Understanding the factors that affect corrosion is crucial for developing effective prevention strategies. So the next topic is about factors affecting corrosions. So there are two primary factors that affect corrosion. First is the nature of the metal, and second is the nature of the environment. So let's explore this in more detail. So the nature of metal plays a significant role in corrosion, and the key points include the position of metals in the galvanic series, overvoltage effects, the area, and the distance between anodic and cathodic areas, and the physical properties of the metal such as grain size and the stress distribution. So the second factors affecting corrosion is the nature of the environment. So the nature also influences corrosion rates. Factors such as temperature, humidity, and pH level and the presence of impurities can accelerate corrosion processes. For example, the lower the pH level typically result in the higher corrosion rates. Next was the corrosion control. First is the selection of metal and alloy using pure and noble metals and cathodic protection and so on. So these corrosion control methods to mitigate corrosion, we can employ several control methods. So this includes selecting appropriate metals and alloys. Next was designing structures to minimize exposures to corrosive environments. And the last one is to implement cathodic protection. In cathodic protection is a widely used method to prevent corrosion, and it involves forcing the metal to act as a cathode. This can be achieved through sacrificial anodes or impressed current systems. So this cathodic protection is organic inhibitors like amines, mercaptans, urea, and thiourea reduces H ion diffusion by absorption. Next was the modifying the environment of metallic coating. There are hot dipping, metal cladding, electroplating, and electroless plating. So this another approach is in modifying the environment. So this can involve as eliminating dissolved oxygen, reducing moisture, and neutralizing acidity. And these steps helps to create conditions that are less conductive to corrosion. In protective coating, applying protective coating is an effective way to shield metals from the corrosive elements. So this choice of coating is materials in critical as it must remain chemical insert under specific conditions. The next one is the corrosion inhibitors. So these corrosion inhibitors can also be used to slow down corrosion rates. Kaning anodic inhibitors kay organic inhibitors shock to effect the reduced corrosions by forming protective films or limiting ion diffusion. Ang methods of application for coating has several methods for applying metallic coating, including hot dipping, metal cladding, electroplating, electroless plating, and metal spraying. So each of these method I have mentioned was its own advantages and applications. Next is the importance of corrosion data. In understanding the corrosion data is a vital for material selections. For example, materials with a corrosion rate of 5 mpy are considered good, while those exceeding 50 mpy are suitable for construction purposes. This corrosion is a significant challenge in the material science and engineering. So by understanding its causes and implementing effective prevention strategies, so we can extend the lifespan of materials and structures of this corrosion and prevention so that we can apply in the future reference. And that would be all. Thank you.